Hey, what's happening, guys? Today I thought I would show you something I'm sure that you've seen before, but I always find fascinating, and that is Lissajous figures. Not Lissajous, Lissajous. And what you can see is one right here, this little rotating circle. And if you look, frequency 1 is 1 kilohertz, and frequency 2 frequency 1 is 1 kilohertz. Frequency 2 is 1.001 kilohertz. And if you look up here, there is our 1 kilohertz sine wave. It's at 3 volts peak to peak, same as the second one. And this one is at 1.01. So what you're seeing is the frequencies remain mostly stable, but the phase changes. And that's what we're seeing here. Now, is this just an interesting curiosity, or is it useful? Well, it's both. It's first and foremost a way to keep an idiot busy with an oscilloscope for hours, because these things are just pretty. And if you're anything like me, you can just sit and stare at them for a while, especially when you start playing with the frequencies and you introduce more lobes into the figures. But for now, we're just going to talk about this really simple, and a way to use the Lissajous figures on an oscilloscope to calculate the frequency of an unknown signal. So just about any oscilloscope that has XY mode will show you this. Up here is your normal oscilloscope. This is what we're seeing. We are seeing amplitude in this direction, the Y direction, and time in the X direction. What we do here is we just switch them around a little bit. Let's go down to a piece of paper, and I can show you a little bit more. Okay, so we can use the oscilloscope and the Lissajous figure to determine an unknown frequency. Aha! But you say, question, can't the scope just tell us the frequency? Answer, yes. But what fun is that? Back in, what was it, the 1850s, when Jules Antoine Lissajous created his little tuning fork machine to do this, we didn't have frequency counters. So, let me show you how we can do this. So in our scope, we're going to have H represent the horizontal deflection, and V represents our vertical deflection. So we can represent our frequencies as F sub H and F sub V, our horizontal frequency and our vertical frequency. So if we put a known frequency into the horizontal, we can find the unknown vertical frequency, and we can use this formula here. F sub V over F sub H is equal to H superscript N V superscript M. Now, what do those numbers mean? Well, let's first simplify this just a little bit, so that we can say then that our frequency vertical is equal to NH over NV times frequency horizontal. So NH is the number of horizontal tangencies, and NV is the number of vertical tangencies. All right, hope you're still with me. Now that's as far into the math as we're going to go today. Let's go back up to the screen for the fun stuff. So the first thing I'm going to do is come back over here, whoops, and set it, my arbitrary waveform generator, so that both of our frequencies are now equal. And what do we see here? We see a simple line going from lower left to upper right. And you can see here it's trying to measure phase difference, but there is no phase difference. Okay? Why do I feel like I did something wrong here? Nope. That says, well, oh, I know what the problem is. One of these guys is hooked up. Let's try this. There we go. Now we're better. So both of them, yeah, it's fine. All right, so that is what they look like when they are the same frequency. We get a single line. What happens when we have a 2-to-1? 2-to-1, we get both of them kind of overlapping in like the trough from one of these. What happens when we get 3-to-1? Well, now 3-to-1, you can see one sine wave here and a separate sine wave here. 4-to-1, 5, 6, 7, 8, 9, 10-to-1. So you see how that works? We're just adding lobes is what we're doing. But if we go back down, so they were the same frequency, and then I'm just going to introduce just a little 1 hertz change, and all of a sudden we've got a rotating circle, which you can see here. There's our steady state, and there's our frequency that is slightly off. Now, if I add a lobe to that by, say, doubling that frequency, you see there's our scoop that we saw the first time, but because we are out of phase now as this thing rotates, you can see both of the waveforms as they're attached to each other. Let's go again, and we'll add another lobe to it, and now you can see there are 1, 2, 3 separate lobes, and if you look here, we are at a 3-to-1 ratio. Let's take it up to 4. Now there are 4, and they appear to be rotating in an opposite direction, but they're still rotating in the same direction. It's just an illusion. Here's 5. Now let's do something a little bit more interesting. We're going to go back to channel 1. We've been playing with channel 2, and we're going to take that frequency and make it 2 kilohertz. Well, what have we done now? You can see we've changed our phase. We've also changed our frequencies. There's 3. What if we go back down to 2 and make it 2.5? Well, that's 2.1. 2.5, which is, again, the same ratio of 2-to-1, and we're back to that same thing. So you can see that the figures themselves are frequency independent and more based on the phase difference between the signals coming in. So this is useful if you don't have a frequency counter. It's some old tech. I'm sure guys are going to say, well, I still use this every day. I'm sure there are some uses for it out there. I don't know what they are. It's not part of my everyday life. But back in the early days before everything came with a frequency counter, this is one way you could determine frequency, and you could also determine phase. It's pretty easy, but it's a useful tool. You know what else is a useful tool? Solderstik spade connectors can be a very useful tool. Now you see in this kit here, they come in all different sizes, taking you from 10 gauge to 22 gauge. These are solid, heavy-duty spade connectors that will do you well. If you're going to use spade connectors, and you really should use some type of termination on any type of connection you make, it just makes things better. It's easier. It reduces the connection resistance. Make sure you get a proper crimping tool for these. Don't just try and do it with a pair of pliers. But yeah, Solderstik spade connectors. Great tool to have in your toolbox. There's a discount down below. You can get them. Give them a try. They are kind enough to be a sponsor on this channel, and I stand by their products. Yeah, Solderstik. Okay, guys, that's all I've got for you today. I hope you enjoyed it. If you did, please give me the old thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons. Big thanks to Solderstik for sponsoring the video. And a big thanks to you guys for watching. That's it. I'm out. Peace.